Alrighty, 9A.4. In this lesson, we're going to do rate of change and proportional relationships. Okay, so we got some vocab to start off here. Okay, first vocab we got, ratio. What a ratio is, it's a fraction that compares two quantities. Okay, so it compares two quantities using a fraction. Now, unit rate, we're going to use that ratio, where we're comparing those two numbers, and it has two different labels. But now the tricky thing with the unit rate is we need to have a denominator of 1. So that's the big thing when it comes to unit rate, 1 unit. So we need to have a denominator of 1. Now, we got some relationships that we're going to talk about. We're going to skip that proportional relationship. And increasing. Now, increasing on a graph, as a graph moves right, so as we go right, it is also going to be moving up. Where decreasing is as we move right, that graph will be going down. And if we break it up into x and y, if you remember, x is going left and right. So as x goes up, meaning as we go right, y is going up, meaning we go straight up. Now and then for increasing, as x goes up, y is going down. Because if you remember, positives go right and up, negatives go down and to the left, depending on if you're using x or y. So example 1, calculating unit rates. Now, we got $412.50 for 15 tickets. We are comparing these two things, the dollars to the number of tickets. So what we're going to say is 412.50 over 15. And we're talking dollars to tickets. Now, I want to find the unit price per ticket. So what is the cost for one ticket? Now, in order to do that again, to find that unit price, we need to get that denominator of 1. So if we want that denominator to be 1, we're going to divide both top and bottom by whatever that denominator is. So we got 412. Now, on bottom, I know I should get 1. So 1 ticket. Now, that 412.50. We're going to have to go off to the side and actually do that division. 412.50 divided by that 15. So 15 goes into 41. That goes in there 2 times. 2 times 15 is 30. Subtract that, we're going to get 11. Bring down that 2. 15 goes in to 112 7 times. So 7 times 15, 15 times 2 is 30, 30, 60, 75. Sorry, 105. Subtract that, we're going to get 7. Bringing down that 5. And then 15 goes into 75 5 times. We get that, 75. Subtract, we get 0. Bring down that final 0. 15 goes into 0 0 times. So it's 27.50, and we're talking dollars. So the unit price for these tickets is $27.50 for that one ticket. Now when we compare this one, we got 336 people on 8 buses. We're going to compare, we're going to see our unit value for how many people we can get on one bus. So 336 will have to go on top, where the 8 buses will go on bottom. And again, we're trying to find that unit value. We're going to have to divide by whatever that, both top and bottom, by whatever that denominator is. So dividing by 8. And then to do that, again, 336 divided by 8. Looking at 8 goes into 33. How many times? 8, 16, 24, 32. That's as close as we're going to get. So 4 times. And it goes 32. Subtract, we get 1, 16. 8 goes into 16 2 times. Therefore, our unit rate is going to be that 42 people for one bus. Now, I can write this a little different. We can say 42 people per bus. Could say 42 per bus. Okay, either way, all the same thing. Okay, now last one here, 441 miles in 7 hours. So unit rate in this case is going to figure out how fast we are going for miles per hour. Okay, so 441 miles in 7 hours. We can figure out our average rate now. Okay, and again, dividing both top and bottom by whatever that denominator is. Okay, we're not going to work through this one. Okay, but if we were to divide both top and bottom by 7, we're going to get 63 miles in 1 hour. Okay, so that's 63 miles per hour. All right, so that's unit rate. Comparing those two different things and then getting that denominator to be 1. And again, to do that, you're going to divide both top and bottom by whatever that denominator is. All right, now unit rate on a graph. Okay, unit rate on a graph, you're going to do vertical change. Again, vertical is up and down over your horizontal change, which is left and right from one point to another point. Okay, and then since it's the unit rate, we got to simplify that denominator to be 1. Okay, so if I have a graph here, we got to figure out 2 good points. Okay, and when I look at that, that is 2 good points. It goes through an actual like 1, 3 there. Okay, and then 2, 6. So to figure out that unit rate or that rate to change, again, the vertical change, so we're going up 1, 2, 3, and that horizontal change, we're going over 1. Okay, and again, it needs to be the vertical change over the horizontal change. So in this case, 3 over 1. Okay, and now vertical, in this case, we're talking distance, and it's in miles. So we're talking 3 miles per 1 hour of jogging. So 1 hour. So, and then that unit rate, since we already have that denominator 1, is going to be 3 miles per hour. MPH represents miles per hour. Okay, that's a nice one. We already gave us that denominator 1. That's not always going to happen. Okay, so in this one, okay, again, finding 2 good points. Okay, that looks like a good one. Here looks like a good one. Okay, now I don't always have to. I could do these ones. Those 2 points. Or I could do those 2 points. Now, I'm going to pick this one because that horizontal change is 1. Well, for this case, let's actually go with the bigger one. Okay, if we go with that bigger right triangle, we're going 1, 2, 3, 4. We got a vertical change of 4 and a horizontal change of 1, 2. Okay, so that rate of change is 4 over 2. And vertically, we're talking about inches. Horizontally, we're talking about days. Okay, we're talking about snow depth in April. Now, that is your rate of change. In order to be the unit rate, again, we need to have that denominator of 1. So I'm going to have to divide both top and bottom by 2 in this case. Okay, and if I was to do that, okay, 4 divided by 2, that gives me 1. And then now 2 divided by 2 is 1, which is going to be 2 inches per day. Okay, 2 inches for 1 day. That is our unit rate for the snowfall, or snow depth, I should say. All right, let's go ahead. Let's do the cost versus number of picnic lunches ordered. Okay, again, pick 2 good points there, and again, you can go. I can use any of these points. Okay, so let's go ahead. Let's use this one. It's gonna make it a little harder instead of just using this one, but it should still get us to the same answer. Okay, so my vertical change there is 3. My horizontal change is 3. Again, vertical change over that horizontal change, and we're talking dollars. And then number of picnic lunches ordered. We'll say 3 lunches. Okay, so for the unit rate in this case is we're trying to figure out the cost for 1 lunch. Okay, in this case, again, we have that denominator 3 for the unit rate. I need that denominator to be 1. So I would actually divide both top and bottom by that 3. which would give me 3 divided by 3, which is 1. So that's talking dollars. 3 divided by 3 is 1 again for lunches. Okay, so that's saying 1 over 1. That's just $1 per lunch. $1 for one lunch. That is our unit rate for the cost in lunches. All right, so now unit rate from a table. Okay, again, unit rate, change in y's over change in x's. And if you remember, y's, those are vertical. X's are horizontal. So the idea is no different than here. Vertical change over that horizontal change in y's, change in x's. Okay, now we're just going to use a table. Okay, x and y. Okay, so you can use any two of those four. Okay, so what we got to do is we got to figure out that change in y and change in x. Okay, so to get, now I see negative 24 to 40. I don't want to deal with that negative, so let's actually pick two other ones. I can go from 40 to 56. I can go any, well, that should be positive actually, anyway. Okay, so from 40 to 56, there I got a difference of 16. Okay, so that's my change in y. My change in x from 5 to 2 is 2, or 5 to 7 is 2. So again, rate of change, 16. So change in y over change in x, which is 2. Okay, and then for y, we're talking dollars. X, we are talking hours. Now for that unit rate, again, we need that denominator of 1. So dividing both top and bottom by that 2, we're going to get 8 over 1, which is just 8. And we're talking dollars per hour. Okay, so there we could be talking about your salary, okay, your hourly wage. Okay, all right, so let's go to the next one. Again, change in y, so you got to pick 2 points. Okay, I'm seeing 6 to 10. That's a difference of 4. That's a change from 6 to 10. Okay, change from 3 to 5 is 2 then, so that rate of change is 4 over 2. And we're talking feet for y and seconds for x. Okay, now again, unit rate, we got to get that denominator to be 1. Divide both top and bottom by 2 in that case. You're going to get 2 over 1, which is 2. And we're talking feet per second. Okay, it's always the top per the bottom. Feet per second. All right, so the next one there. Okay, change in y, change in x. We got a change of 3 there, change of 1. So rate of change is 3 over 1, and we're talking dollars per week. Okay, unit rate, guess what? We got that denominator of 1. So we're saying $3 per week in this case. All right. So there's our unit rate given a table. Okay, if a proportional line. Okay, so proportional line, if in the form of y equals mx, okay, where m is going to be a number, the rate of change is m. Okay, we determine m, we'll talk about this a little later, but m is what we call slope. It's exactly what we've been finding. Okay, and if it's proportional, it's going to go through 0, 0. Non-proportional now, it's one that's going to have that mx plus b, where m is that slope, okay, and b is what's called the y-intercept, which we'll talk about later. Now, if it's non-proportional, it will not go through 0, 0. And again, 0, 0 is that point right here where the x and y axis meet, which we call the origin. Okay, so let's go ahead, graph each function using a table of values, determine if the graph shows a proportional relationship. Okay, so let's go ahead. We've done this before, and we're going to graph it. And we're just going to pick, let's say, 3 values. We're going to do 0, 1, and 2. We're going to plug those in. So that's saying 3 times 0 plus 5, which will give us 0 plus 5, or 5. This one's going to be 3 times 1 plus 5, which would say 3 plus 5, or 8. 3 times 2 plus 5, which would be 6 plus 5, or 11. Okay, so let's go ahead. Let's plot that point. And again, if it's in this form, it is a line. Okay, so 0, 5, that's going to be a point right there. 1, 8, right 1, up 8. And finally, right 2, up 11, which gets us off the graph. But then we'll draw our straight line. Okay, so is the function proportional? And again, in order to be proportional, it has to go through 0, 0. Did it go through that point of right here? It did not, so therefore it is not proportional. Okay, how can you tell from the equation? Okay, in order to tell it from the equation, that plus 5, okay, that is what's going to determine from the equation that it is not proportional. Okay, again, because y equals mx plus b, we had that b value of 5. Now, from the table of values, we could tell it's not going through 0, 0 because we had that ordered pair of 0, 5. So the input of 0 had an output of 5. From the graph, the line did not go through 0, 0 or the origin. That is how we would determine that from the graph, because again, it did not go through that point that was right there. All right, so if we go y equals negative 2x, okay, so determine if it's proportional, we're going to have to do an input of 0. Now I'm going to do, let's do negative 2, negative 1, 1, and 2. Okay, and again, we're taking those x values, plugging it in. So that's saying negative 2 times negative 2, which will give us 4. Negative 2 times negative 1, which will give us 2. Negative 2 times 0, which will give us 0. Negative 2 times 1, which is negative 2. And negative 2 times 2, which will give us negative 4. So now we can plot those points. Negative 2, 4, that's saying left 2, up 4. Left 1, up 2, 0, 0. Right 1, down 2. Right 2, down 2. Okay, now, once we have those, this is a line. So there's our line. Okay, is this proportional? Yes, this is proportional due to the fact that it went through the origin. Okay, from the equation, we could tell it was in the form of y equals mx. Okay, no b value. Okay, if there's no b value, if you just see a coefficient in x, those will be proportional. The table of values, input of 0, had an output of 0. Therefore, it went through that point of 0, 0. And on the graph, the line went through that point of 0, 0. All right, so that is determining if something is proportional and graphing that line. Okay, so one last thing. Okay, 2 pizza shops open up right next door to one another. Both displays a sign outside advertising their prices. Okay, so what we're going to determine is which shop offers the better price on pizza. Okay, so on that first one, $3.50 per slice. Okay, that gives us the unit price of a piece of pizza. Okay, right there, it's $3.50 per slice. Now, on this other one, piece of pie, okay, there's the peace sign. Okay, we need to determine that unit price. Okay, so that way, when we compare two items, like when you go to a grocery store and you want to compare the price of them, you need to compare the unit price, not just the price that's shown. Okay, so in this case, hey, we're given that graph. Now, again, when we're doing this, we're going to have to figure out 2 good points. Okay, there's a good point, there's a good point. Okay, and we can fill in the gaps here. It's going up by 3s. And we can determine the vertical change over the horizontal change. Okay, vertical change, we're going from 6 to 9, so that's a change of 3. 2 to 3, that's a change of 1. And again, we always do the vertical change over the horizontal change. And vertically, we're talking cost, so that's going to be dollars. And this is 1 slice is what we're talking about. Oh. And on the horizontal axis. Okay, right there with those 2 points that we picked, we actually got the unit price right off the bat. Okay, if you were to use this one, it's going to be 6 over 2, and you're going to have to simplify that, still going to get you to that 3 over 1. Okay, now, if the pizzas taste the same and they're both good pieces of pizza, I'm going to buy the cheaper one. Okay, so which shop offers the better price on pizza? That's going to be the piece of pie. Piece of pizza. Okay, and because it has that better unit price. All right, so that is lesson 4 for unit 9A. Make sure to start working on your homework and have a good day.